You ever wonder how AI actually thinks? I mean, we see it writing entire essays, picking our faces out of a crowd, answering these ridiculously complex questions. But we know it doesn't dream, it doesn't have feelings, it's not imagining things like we do. So, what is actually going on in there?
Right. Let's just get straight to it. If it's not thinking like us, then what's the deal? Well, the secret is this absolutely fascinating system that was inspired by, you guessed it, the most powerful computer we know of, our very own brain. And this right here, this really nails the core difference, where we have these abstract, fuzzy things like dreams and feelings. And AI is all about recognizing patterns, running a ton of math, and just refining everything through sheer brute force repetition. It's a totally different kind of intelligence.
To really get this, we've got to look at the architecture, the engine that powers pretty much all modern AI. And that engine is something called a neural network.
Okay, now when we say neurons, it's super important to know we're not talking about squishy brain cells. Nope, these are mathematical functions. Think of them like tiny, simple calculators, each one grabbing some data, doing a quick calculation, and then passing its result to the next calculator in line.
So here's the thing that's really key. The genius of a neural network isn't in any single one of these little math neurons. The real magic happens when you get a whole bunch of them together, like a massive number of them.
On its own, one of these neurons is incredibly simple. It can't really do much of anything. It's kind of like a single person whispering in an empty football stadium. It just doesn't have much impact by itself. But when you connect millions or even billions of these simple neurons together in all these layers, well, something amazing starts to happen. All of a sudden, this giant network can start to see images, hear sounds, and actually learn from insane amounts of data. The crowd itself becomes intelligent.
A really great way to picture this is to imagine a huge crowd trying to solve a puzzle. The first group right at the front takes a quick stab at it, a first guess. Then they pass their answers to the group behind them. That next group looks at the first guesses and makes them a little better. This keeps happening layer by layer, with each group improving on the last, until the very back of the crowd comes up with a super accurate answer.
All right, let's follow the data on its first trip through the network. This journey, from the moment it goes in, through all those layers to the final answer, this is the network's very first attempt at making sense of something. And this whole journey has a name, a technical one. It's called the forward pass. It's basically the network's best shot, its first guess, based on everything it knows at that moment. Now, this is where it gets really cool. Imagine you feed the network a picture of a cat. The very first layer of neurons doesn't see a cat, not at all. It just sees simple things like basic lines and edges. It passes that info on, and the next layer might combine those lines into simple shapes, circles, squares. The layer after that might recognize something more complex, like the texture of fur or the pointy shape of an ear. So after that image has passed through all those layers, what comes out at the very end isn't just the word cat. It's a probability. It's the network saying, okay, based on all the features I saw, the edges, the shapes, the fur, I'm 98% sure this is a cat. And that is the result of the forward pass. But look, making a guess is only half the story. The real secret to how an AI gets so smart isn't just in making predictions. It's in its incredible ability to learn from its own mistakes. And this, right here, this is probably the most important question in all of machine learning. A guess is just a guess. So what happens when the network gets it completely wrong? How does it ever get better? Let's say the network looks at our cat picture and confidently says, dog. Whoops, that's an error. If there was no way to fix this, the AI would just be dumb forever, making the same mistake over and over again. This is where the learning really happens. It's a process called backpropagation. Essentially, the network calculates just how wrong it was, and it sends an error report backward through all the layers. Every single neuron gets this feedback and makes a tiny adjustment to its own settings, basically learning, next time I should have paid a little more attention to that feature, and a little less to that one. It's really just a very, very sophisticated version of trial and error. The catch is, this whole cycle of guessing, checking the error, and making a tiny adjustment, it happens millions, sometimes billions of times. And with every single cycle, the mistakes get smaller and smaller until the network becomes unbelievably accurate. So when we zoom back out, you can see how these two big processes, that forward pass for guessing and back propagation for learning, how they work together in this constant loop to create what we see as artificial intelligence.
So the next time you hear someone say, the AI is thinking, you'll actually know what's going on under the hood. It's not some unknowable magic. It's just a really clever system of math and massive, massive repetition, where the connections are constantly getting tweaked based on whether they got the right answer.
And this exact process, it's the engine behind so much of the tech we use every single day. It's how your phone's camera instantly finds faces. It's how ChatGPT gets the nuance of your questions. And it's how self-driving cars can see and understand the world around them. It's all just recognizing patterns and learning from mistakes on a scale we can barely imagine.
So no, an AI doesn't think like a human does, but it does something that's maybe just as fascinating. Through this relentless, high-speed process of trial and error, it learns patterns with so much depth, so much complexity, that eventually those patterns start to look a whole lot like understanding.